All right, so this is video 2 for acids and bases, and we're going to talk about pH. So our question here is, what is pH? So pH is a scale that helps us determine if a substance is an acid or a base. And our scale is based on 1 to 14. 7 here in the middle, this is neutral. 1 is going to be your most acidic. And 14 is going to be your most basic. So what that is telling us is that anything that falls in the middle of these two ranges, so in the middle of 1 to 7, and in the middle of 14 and 7, these are going to be your bases, and 1 to 7, these are going to be your acids. Acids are based on your hydronium, right? So hydrogen ions, and bases are based on your hydroxide ion, so that OH minus. So the more H's we have, so the more hydrogen or the increased concentration we have, we're going to be more acidic. The more OH concentration we have, the more basic something is going to be. So from 1, we have our strong acids. And 14, we have our strong bases. Everything in the middle ranges. So they get weaker this way until we hit 7, and they get weaker this way until we reach 7 from the top. So our pH scale, like I just said, is based on the concentration of H plus and O minus ions in a solution. And again, this tells us if something is acidic or basic. Right, so we'll look at the scale again with some like real life examples. The image here, we have our scale going vertical instead of horizontal. We have 7 here in the middle, and the examples they give are human blood or tears. So when something is neutral, the concentration of hydrogen is equal to the concentration of hydroxide. Remember that these brackets mean concentration. We'll be using these a lot throughout this. Okay, so when something is acidic, like gastric juice, this is stomach acid, hydrochloric acid, HCl, falls in this range as well. Wine, black coffee, rainwater, right? We hear the term acidic rain. This is when your hydrogen concentration is greater than your hydroxide concentration. When we have bases, so milk of magnesia, you take this if you have indigestion. Baking soda falls into this range, and bleach, any of your drain cleaners, your soaps, those are going to be more basic, and that is when your hydrogen is less than the concentration of your hydroxide, right? We have citruses here too. We know that oranges, lemons, limes, those guys are acidic, they're tart, right? And this little colorful wheel down here, this is a type of indicator that we're going to talk about in a later slide to show you what the relative pH of something is. So a little extra, this isn't really going to be a major thing we focus on, but a little extra is how we calculate pH. So pH is a concentration of something, right? So we calculate this using a logarithmic equation. So if you're in calculus or pre-calculus, you've probably seen this already. If not, that's fine. So it is actually the negative log of our hydrogen concentration, right? Remember, hydrogen is also H3O plus, hydronium ions. So because our pH equation is based on 10, we don't even really need a calculator to solve this. If you notice in the table, when our concentration is 10 to the minus 1, our pH is 1. So whatever the exponent is there is going to be our pH. So that's our little trick there. pOH is something that's also measured and calculated, but we don't typically talk about it. We usually just refer to it as the pH of a base. But we can calculate the pOH the same way, so the minus log of the hydroxide ion, right? Or, simple, we can just subtract the pH from 14, right? If you notice on the table, 10 to the minus 2 is a pH of 2. 14 minus 2 is 12, so our pOH is 12. Again, this is just tidbit extra information for you guys that if you move on to AP or you take college chem, you will see this there as well. So I just wanted to throw it in for you guys to get familiar with. Let's move on to indicators. So table M, this is in your reference table. They will show us a color change to tell us if something is an acid or a base. Now, these are great because they help us identify roughly whether something is an acid or a base, but it doesn't give us a precise pH. So let's take a look at the first one, methyl orange. So it says, if you notice here, approximate pH range. So it works best with something that falls in the range of 3.1 to 4.4. So that means if anything, excuse me, is below 3.1, it is going to be red in color. And if it is above 4.4, it's going to be yellow. So if we have something changing to yellow, it's going to be 4.4 or higher. We don't know specifically what it is, right? So if it's red, we can assume that it is 3.1 or lower. Now, each of these indicators are used for different things. So methyl orange, this is going to be for your strong acids. Bromethymol blue, this is going to be for acids and bases. Notice the range falls in the kind of neutral zone. So this is going to be for acids and bases, right? Phenolphthalein, 8 to 9. This turns a really cool pink color when you do titrations with it. We're going to talk about titrations in a future lesson. But this is for your strong bases. Litmus, this one is used very often. It's also referred to as litmus paper. So it will change from red to blue depending on if it's an acid or a base. Again, it's good for acids and bases. We notice that it goes from 4.5 all the way up to 8.3. Bromocreosol green. This one has a special place in my heart because I used it every day when I worked for the Water Authority in the lab. It is used best for strong acids. And last but not least, we have thymol blue. So 8.0 to 9.6. We know that bases are higher than 7, so we're going to use this one when we're working with strong bases. Right, so different indicators, different uses, different colors, but please, the big thing to remember with indicators is that they do not give us a precise pH reading. They kind of give us a range and an idea of what we're working with. There are ways to measure pH using meters, which are more accurate representations of that, as well as some more manual hands-on methods that we'll talk about in a little bit later in another lesson. But for now, this is where we're going to end pH. So it's a short and sweet video for you guys this lesson. Please check Google Classroom. Make sure you're keeping up with all of your work. There will be an assignment or two posted that goes along with this lesson there, and then we'll keep going. So if you have any questions, as usual, you know how to reach myself as well as Miss Anastasi. So keep going strong, guys.